So now I hand it over to Ranjish. Ranjish represents Nirmata, wherein Nirmata has their open source Kyverno project, CNCF incubation project. Ranjish will ideally talk on policy based Kubernetes governance at scale. So, Ranjish, all yours. All right. Yeah. Rahul, can you please? Okay. Okay.
Okay, so good afternoon to all. And It's a great crowd. And I was thinking of asking some baseline questions before I get started, but I know now where the crowd is today. And some of the questions that were discussed earlier, and I have an answer to it. For example, the tools that he mentioned. Just a quick point on that, and then I'll move to the session here. What we have seen, at least in the open source world, is that yeah. So what we have seen, at least in the open source world, is that many of these projects don't come just as a hobby project. At least those in the CNCF landscape, many of them have actually a problem statement to solve. So just because I am on Kyverno, I would like to say how we differentiate from OPA Gatekeeper. So I think one of the challenges that were existing at that point in time was that you did not have kind of a Kubernetes native policy engine which could be easily let's say authored and maintained by the community. So that was one of the fundamental I think problems that we solved. But then over a period of time we also covered a lot of use cases, and many of them actually you folks were asking earlier, and I can show you some of those policies which are already available, like for example any UID thing and pod security standards. All of them are available for you guys to use it, right? So the kind of range that we have gone obviously with community support has been enormous, right? And the one of the single reasons, I mean, you might say it's not a big deal to learn a new language, but one of the single reason at least I have seen, and I think the organization has seen consistently is it's very difficult to manage policies when you have a language which you need to learn, and what happens after those people who have actually created those fancy policies and they leave. What happens to those policies, right? How do you maintain it? Learning curve is very hard to take. So I think those are real problem statements to address. And then of course the subject matter part and many of the topics, and that's again where I think it's a good thing to actually come later in the program and then talk about it, because a lot of things have been spoken about and I can kind of refer to them and build on top of it. But also there's a challenge for me today, because many of you have spoken about one single word, which is policy. And and these policies have been spoken in different contexts, right? So there's an operator overload. So I need to define my to you so that you understand where we fit in. And again, when it comes to security, you ask, do we need so many tools? But even if you look at physical security, you don't just have a lock for the gate, right? You have multiple locks over a period of time before you have those tijoris kept somewhere there, and you have multiple locks there. So similarly, in a virtual world, or in a Kubernetes world, including, you will continue to see many of these tools coming in. I think it aligns to the concept of defense in depth, which I think Rahul and others also mentioned. And also we say security, best security is redundant security, right? And obviously the like Ravi was talking about, it's a huge business to actually breach in, and that everybody is smarter, and they are always one step ahead. So we need to be also smart. So therefore, I think it's important to have more tools. So just coming back to the topic of the day, which I'm going to present, it's about policy-based Kubernetes governance. Now, governance is also a term which Arvind had mentioned earlier, and this is about Kubernetes governance. Again, a topic which is not mentioned much in many of the public forums, and also therefore it's important for me to explain a little bit as to why we are talking about governance in the overall context of Kubernetes parlance and the ecosystem. Why we need it, what it is, and then introduce you to Kyverno if you are not aware of it. So yeah, by the way, I understand you all have a very good understanding of Kubernetes ecosystem. How many have known about Kyverno, or how many have implemented Kyverno in your environments? Anybody who has already implemented? Okay. So very few. So I think for the rest it may be useful, and then we will talk about some use cases. Of course, we have around 290 policies in the community, so I'm not going to talk about all, but there may be some key use cases which we can talk about if time permitting. So So, to start off with, right? I mean, some of you have already mentioned about this earlier, the 4 Cs of cloud native security. I think it's very important, since we are in a cloud native security meetup, to kind of keep this as a reference, because that then it becomes very easier for you to relate, and it also helps you remove the clutter of the tools, right? So what kind of layers? So you might think those tools are all doing the same thing. For example, many a times, unless we really understand what Equinox is doing, what Kubernetes is doing, you might even say Kubernetes is same as Kyverno, right? But then, you have to go into details, and that's where I think security experts really are valued, because you understand what you do. And where we essentially play around, right, when we talk about Kyverno here, is in the cluster and container layers. Okay, cluster and container layers. And, of course, there are multiple tools and multiple strategies that you follow on the cloud and the code layer. There are also certain components in the cloud and the code layer which would come under what we try to do. So I have just highlighted some of the points here. So, obviously we will have host when I say the host OS, compute, storage, and network, which comes under the cloud part. Then you have the container orchestration platforms. It can be of any distribution, public cloud or open source, or the standard distributions like OpenShift or Rancher. Then the container runtime, right? And then at the code level, you will have image registries and software supply chains. These are some of the areas which I want to kind of map to these layers to say where we actually come in, okay? But fundamentally, this is about cluster and containers. But there are also certain other areas where we come in indirectly through the Kubernetes interfaces, like some of the ones which Rahul was also referring to, like the CNI and CSI and so on, right? So essentially, it's about configurations here. Fundamentally, it's about configurations. Now, why are we talking about configurations here, and why this is a problem statement, right? So I think I want to establish the problem statement here first. Again, an analyst statement here, and I think I think this trend has been going on for some time, but now it's become kind of formalized as a term called platform engineering. Fundamentally, I do not really acknowledge that as a new word, because platform engineers have been there for a long time. But I think the meaning of platform engineering here means that now you are enabling the DevOps teams to kind of empower the end users. And end users here typically are developers in any organization through what we call as the internal development platform, right? So IDPs. Now, of course, IDPs cannot exist standalone. You essentially have to integrate the entire pipeline and beyond till deployment. Now, when you are empowering your end users, let's say you have the platform engineers, you are managing the platform, whether centrally or let's say you have a distributed model. When you're empowering end users, it's very important that you also ensure that they are ruled properly, right? Because at the end of the day, there is only so much you should allow them to do. At the same time, you should create this kind of an environment, saying that okay, there is a lot of let's say openness that the developers have to access certain aspects of the environment, which means that there should be a feeling that the developers are not blocked at a level, so that the release velocity is maintained and also increased. But at the same time, they should not misbehave, right? So I would say the term that we use is governance. Now, governance is a way to shape behaviors in a Kubernetes environment, is how I would put it simply. Now, there are other terms like you might have heard of security posture management. So here I would say it's also like KSPM, which is Kubernetes security posture management, where configurations play a very important role. And the reason being simply that, Kubernetes, as you see, is not a single component. Orchestration and management layer is just one of them. But then you have a lot of other native and custom resources which together form that reference architecture for microservices. Like for example, service mesh, or observability, load balancers, service discovery, a lot of things, right? Databases and so on. So many of these things, when they're running on a Kubernetes environment, each of them have configurations, and security context is the very easiest way. Now, I was just thinking about security context, and this is a very good example that I gave. Now, every pod will have a security context. Now, if you look at security context, essentially, I think there are around 20 controls. Let's say if you are talking about from a pod security standards perspective, each of these controls may have around 3 attributes or configurations. That's around, that itself around 60 configurations. Now, this is for one pod. Imagine if you have 1,000 pods. Not every pod is same. which means that there are permutations and combinations of the configurations, and these keep changing, right? These are dynamic. How do you manage that at scale? So those are the places where I think it becomes very important for you to codify policies, which can then help you manage those configurations, right? So, and which is where we believe Kubernetes is very complex to secure at scale, secure and scale and at scale. And there are multiple examples which are being given. Some of them are not directly related. For SolarWinds was not essentially a Kubernetes break-in, but it still was a supply chain security break-in, which can be applicable to Kubernetes as well. But then, crypto mining, we have spoken about ransomware and so on. So the way I was trying to think when Rahul was talking about it, and also the minimalistic aspect was talked about, was to see that, this is one more layer, right? So we come in actually as a layer after the supply chain, so that if somebody has missed out something at the supply chain, we prevent. Now, if we also fail somewhere, then these guys are there, right? So essentially, that's how I see this as a kind of a complementary and kind of a complementing way of securing the entire pipeline, so to say, not just at the pipeline level, but also at the environment level, right? So and these are some of the top risks. Again, there are hundreds of such top 10s that you might see, but OWASP had also come up with the top 10s. And if you look at top 10s here, many of them are related to configurations, okay? And like workload configurations essentially around pod security. There's also a lack of centralized policy enforcement and so on. So, many of these, guidelines, for example, NSA, the National Security Agency, also has Kubernetes guidelines. They also allude to the fact that you should have some sort of a policy engine, which can actually enforce many of these policies, right? The reason being that if you look at one of the fundamental reasons for security breaches, it's misconfigurations. So look at it this way, right? So when you say that somebody is breaching your environment, right? It's not like he is manufacturing a defect. The defect is manufactured by you, right? It's just that you don't know about it. So it's not something like, he's unlike in other places where you actually, let's say, dig a cave or a tunnel and then you get in. Here there's no such thing. It's actually a tunnel which is already left by you unattended and somebody is trying to enter it. And one of the ways you can create that kind of a breach is using misconfiguration. So I think the best way is to be visible, to bring in the right visibility on all the configurations so that you understand where exactly the misconfigurations are, and then you try to remediate it immediately. So which is where preventing misconfigurations become very important. And what is the cost of missing guardrails, right? So we call it as more of guardrails than gates. So we are not really saying that we are blocking everything, but you should have a proper boundary of things so that the users should know exactly where to stop, right? Where your limits are. Now, typically, if I do it representatively, essentially this is how the order should be, and think of this as a cluster, right? And think of this as a cluster where you want everything to be in order. If you don't have the guardrails, this is how your cluster would look like, essentially. So it's like a physical environment where you have law and order being maintained by the police, and this is what would happen if you don't have those governance. So just to quantify, because many people talk about ROI and so on. So one of the ways you can quantify this is using a model which was proposed in the context of software development methodology, where it was said that usually defects actually get created. As I said, if I go back to the previous statement which I mentioned, defects are created by you, and usually these defects get injected very early on in your development cycle, right? It's usually at the coding and unit testing phase when these defects are created, and it's also resolved to a large extent in most cases. Ideally that should be the case at the pipeline layer. But then there is a good portion of that defect which goes into the cluster. Now, the principle here says that you should try to prevent many of these defects or most of the defects before it gets into the deployment phase or the production phase, simply because the effort required to prevent, effort required to actually correct those misconfigurations are much more if it goes to the production or deployment, and therefore time is money, and therefore the cost attached to it as well, right? So there's quite a very high cost that you'll have to take. So very simple example would be that if I translate that to misconfigurations, let's say if one misconfiguration takes around 15 minutes for you to detect and resolve in the pipeline, it might take around 20 days for you to really pull that container which is running a critical workload or critical application to be brought back to your pipeline, right? So those are the kind of timelines that we are looking at, when we are allowing these misconfigurations to go into the production. So what can policies do for us, right? So typically in general, every enterprise has policies, this is more of a general statement that I'm looking at, but then I'll show you how it maps to the governance in Kubernetes. Essentially, policies, if you look at any organization, they will have standard policies. It's not just necessary about Kubernetes, but also about HR policies and other policies, right? So typically, there are, if you look at misconfiguration, essentially it's about, again, the do's and don'ts of what you can do in an organization is where you have policies. They are also contracts, right? They are also contracts between different roles. And in the Kubernetes parlance, it would essentially mean DevSec and ops personas. Essentially, it's a contract with also separation of concerns. Now, separation of concerns meaning that you will actually assign ownership. You will be actually assigning ownerships to these configurations because even in a one single deployment, the configurations may have different owners, right? So essentially, you may have to separate that ownerships very clearly so that you understand, that the users understand or the personas understand what configurations need to be maintained by each of them. So that is also something which is provided using a policy contract, right? Also enforcing security controls. And again, there are some examples which I can talk about. Best practice consistency. So some of the best practices that we talk about are not necessarily security controls or even compliances, but they are good to have, right? So like we were discussing about mounting volumes on pods, there could be some security controls that can be written on that, or it could be just a best practice that you can adopt to avoid that, or labeling, right? For that matter, labeling different workloads based on lines of businesses could be a best practice so that you ensure that all the right costs are attached to the right workloads and so on. Also, compliance is an area where you can use policies here. And of course, all of these are underlined by automation. So, automating, how can you automate these policies so that it's not manual in nature and take your time, right? So essentially, it's about checks and kind of, let's say, auditing of many of these configurations or prevention of these misconfigurations where these policies come in. Now, if you translate that to what is required from a Kubernetes governance point of view, and this real life policy example to governance, what we thought about, and this is where the solution that we were thinking about, is to come up with a Kubernetes native policy engine, which can have policies run as resources. So essentially, when I say Kubernetes native, I think probably there are two areas which I can talk about. So one is, of course, YAML is a language which everybody understands. As long as you are a DevSecOps persona, you are working in Kubernetes, you definitely understand YAML as a language. You don't need to pick up a new language, right? So that makes it very easy for you to create policies. At the same time, if your policies are running as resources, another custom resource in the environment, you can use all the existing tools, right? Like kubectl or Helm or Kustomize and so on. Again, you don't have to bring new tools. So to going back to his point, you are not creating additional set of tools just to introduce another tool into your ecosystem. You are actually using existing tools, existing languages to create policies which can address many of your issues, right? So that's something which you need to keep in mind when you're looking at the right tool, for enforcing governance, right? So, and this is what at least we have been trying to do here. Also, that brings in extensibility, which I said, it's not just language. I think it applies to some extent to other tools as well in many of the other languages, like Ansible, I think also claims. Again, Ansible is not a similar, functionality here, but they also say they are using YAML because you create a consistent language across your team, which everybody understands. You don't have different languages for different teams to actually operate across each other. Now, how do you maintain, right? So again, these are something which, as I said, maintainable by Kubernetes domain experts. So because it's all in the Kubernetes domain, anybody who's working in Kubernetes will understand. Finally, policy as code. So policy as code, as I said earlier, it's about codifying many of these policies as declarative statements, which can then be applied across environments at scale. So what we did by bringing in Kyverno here as a project, and this is again a CNCF project, was to essentially align with many of the principles which are mentioned here. This is something which we love to showcase or flaunt in terms of numbers. I did not introduce Nirmata or me earlier, but let me introduce at this point in time. So Nirmata is the company which created Kyverno. In fact, we realized the need for governance, I would say around 2018, when we had, or even before that, because this was part of one of our other product, which was called the Nirmata DevSecOps platform. At that time when we had multi-cloud management capability, even now that exists. But we realized that policy in itself is an important aspect to be considered and focused on. And so therefore we created this project, and then we donated to CNCF back in 2020, November. Just last year, July last year, we became an incubating project, and I hope to have graduation very soon. What we have seen over the last 3 years is that there's a lot of traction in terms of the open source project itself. A large number of organizations have adopted it globally, and there are a list which are publicly acknowledged names in the GitHub community, so you can go and check that out. But this is where it stands today, right? So 2.5 billion plus image pulls, 4.5 thousand GitHub stars, 300 contributors, and 2,400 plus Slack members. So one of the, let's say, objective today is also to introduce you, some of you at least, to this community. And if you have the interest and requirement, maybe you should check out the community and see if you can contribute as well, right? And consume. So why Kyverno? As I said already, it's all YAML-based language on which you can write the policies. And because it's all Kubernetes native, the processing is also pretty fast. In terms of policy types, we have again going back to the point of OPA Gatekeeper versus Kyverno. OPA Gatekeeper does not support the kind of range of policy types that we have. So validate is something which everybody supports. Mutate had come in very recently with OPA, but we are supporting it right from the beginning. We also have generate capabilities, and this goes back to the secure multi-tenancy use case which Arvind had earlier, wherein you can actually create new policies on the fly, based on an event trigger, right? So if you're, let's say, creating a new namespace, somebody is asking for a new namespace. Let's say your developers are asking for a new namespace. You can write policy which says that I cannot obviously give a namespace bare naked. I would need to attach network policies, storage class policies, RBACs, node isolations, resource quotas, and so on. So how do I do that? Either you can manually configure all of those together and then hand over the namespace to the user, or you use a generate policy, which can automatically create all of these policies at the instance when you're also creating the namespace, and then hand it over all together as a package, right? So that's one example of a generate, right? So those are powerful means of actually automating a lot of activities that you may have to otherwise do manually. And more importantly, it's just not about automation, but also the fact that you may miss some of those things, right? If you were not applying some of those policies, that can actually lead to security breaches. So those are some of the kind of, let's say, additional capabilities. There are a lot more functions which I will talk about in the subsequent slides, but at this point in time, generate is another major policy type which I want to emphasize on. Again, anything on Kubernetes. When I say anything, so let me just put a quick list here. So anything on Kubernetes, whether it's kind, names, labels, annotations, operations, as long as it is in the Kubernetes ecosystem and the API server understands it, you can write a policy based on that, right? You can have a match to that particular resource and do whatever you want to. So mainly the policy types are validate, mutate, generate, and verify images. There are also policy exceptions and so on. So it becomes absolutely simple. And I think this is a problem statement to solve by anybody. And this kind of reduces a lot of other tools, if you have there in the market. And as of now, by far, I think I see only OPA Gatekeeper there. I don't see too many other tools because, you don't need to. I mean, we actually have simplified the problem here, right? So you can, irrespective of whatever you have in a Kubernetes environment, tomorrow you create a custom resource, we can actually put that as a match and then create a policy around that, right? So we do not prevent you from excluding anything. So you can have any custom resource or a native resource today in Kubernetes, which can be then used. And if you look at the policy example here, it's very simple, checking a label here, right? And this is how policies are written. And there are already 290 policies today. And I'll just quickly show it here because there were some questions. So if you go to the community here, community site, okay. So this is the community site here, right? So here, you just do a quick search. So you were talking about any UID. So this any UID part comes here. So this disallow the security context. If specifically in the case of OpenShift, right? So you don't allow the 000 here. So you have to set up any UID value here for with the policy, so that's in the security context, so that you prevent anybody from overriding, right? Essentially, it's about overriding your configuration. You can prevent that. Okay, so that's one example. There are a lot more examples around mounting secrets, for example. So I think the question was, where do you keep the secret? So again, there are policies which are written already available, which says that if your security is actually stored as an environment variable, do not allow, right? So you should have it as an external, it should be kept in an external storage, maybe Vault or somewhere else. So those kind of policies are already written. And then you can also create more custom policies on top of it. So if you don't see those policies here, it's just a matter of creating another set of policies, either customizing the existing ones or create new ones, right? Just a quick point on the architecture again. Hopefully by now you have understood where exactly this is positioned. Now, when it comes to Kyverno, there are three parts to its functions when it comes to the pipeline, runtime, and also existing resources. So we have a CLI for the engine, which can then be used by developers in the pipeline without running a Kubernetes engine. It's a kubectl plugin, which can then be used either directly or integrated with your pipeline, integrates with GitHub Actions or Jenkins, which can then automate validation of your policies much before it goes. So it's kind of the extreme shift left, right? So already it's a shift left if you have it in a prevention mode, but then you also can put it in your pipeline so that you can prevent, much before, identify the issues and solve it. So that actually goes back to the Capers-Jones model, which I mentioned, where the earlier you detect the problem, it's easier for you, lower cost for you to actually solve those problems, right? So you have a CLI option. You also have the policy engine. So policy engine, as you can know, it works very closely with the API server. So, after authentication and authorization is where it is handed over the request, the deployment request, or any other request that you have sent through the API server goes through, the policy engine, where it does an admission review. And only based on the logic, it will decide whether to allow or drop the request. And if it's allowed, then it gets persisted in the HCD database, right? So that's essentially how it works. Of course, what we have done also, because we understand that it's in the critical path. Yeah, before that, let me just quickly also cover the runtime scans. So CLI, the policy engine, which is the admission controller, but also we have something called background scans, which means that if you already have workloads in the cluster, what do you do with that, right? So obviously we do not want to disrupt that, but at the same time, we would do a scan periodically to show what are the gaps today in the existing workloads and what can be done about it, right? So then you can decide whether to remediate, by bringing it down, or do some other means to remediate those issues, right? Or trigger something else. So that's also one aspect of Kyverno. Just getting into the architecture, what we have done with the latest release, which is 1.10, is to make it truly distributed. So already Kyverno had been containerized and has been fairly distributed, but now it's 100% distributed in the sense that all the controllers, there are 4 controllers, all of them are running separately. You can scale them independently, and you can run it in HA mode as well, which means that being in a critical path, it's very important that Kyverno is up and running all the time. Though we have an option to actually have a failure policy to ignore if Kyverno does not work, but ideally you should have it always in your environment, and that's where we have made it truly scalable and distributed, right? As I mentioned, there's already a CLI. So some of the advanced features here beyond validate, mutate, generate is policy exception. Now this comes back to about what he mentioned about zero trust. One of the fundamental principles of zero trust is just-in-time access, right? And what happens if you have given a global, you have set up a global policy, which is, let's say, cluster-wide and maybe user-wide. And what happens if somebody wants to have an exception to do something? For example, you may do a blanket deny, a default deny for access to creating pods. Okay, let's say, and you can actually put time bound also. You can have a time bound saying that from this time to, let's say, 1 hour time period, let's say, or 9 to 5, let's say during the business hours when my traffic load is highest from a customer perspective, I do not want anybody to touch my cluster. I do that as a blanket cluster policy. But then there may be some emergencies, or for whatever reason, an admin wants to go in and create that, right? So for the admin, you give an exception, policy exception, for a specific period of time. And that's where the policy exceptions are very, very valuable with time-bound policies. And that has been something which we have added recently, which essentially comes around saying that don't trust anybody, but if somebody wants to do something within the period, then how about giving them some exceptions? Cleanup policy is again a very useful capability, where if you have resources which are unattended and you want to clean them up, okay, you can do that using cleanup policies. One very good example would be bare pods or ephemeral pods you have created for debugging. They may not have controllers managing them. So what do you do, right? So somebody has to notice that and then bring it down. You can actually write policies to clean them up, right? So those are policies which will also bring you a lot of cost efficiency. If you want to improve the effectiveness of your clusters as well, right? So there are multiple such use cases that you can look at from a cleanup perspective. Extensibility via external service calls, and this is where I was talking to Rahul. I was asking Rahul about that events part. I think it's an interesting use case where extensibility could be helpful. So Kyverno had already been able to call OCI registries, talk to API server, and do config map lookups. But in the latest release, we have also come up with extensibility of this capability, which means that you can make an API call, you can do a get or post to any service endpoint as long as it is in the cluster. Okay, so for example, if and this is again thinking out loud, right? So I was just thinking, if let's say Prometheus sends something, or Falco sends something, or Kubernetes sends something, maybe that could be received, or it can be the other way around also, where Kubernetes is sending something to you guys, and if you have the capability to use it, then you can take certain actions out of it, right? So let's say if you say that there is some configuration which is again part of pod security, as you said, which is not set at the LSM level, let's say, or eBPF level, then obviously there is no security there. So why not notify the developer that, hey, why don't you have a policy which essentially stops it at the pod security level? So I think probably some of these things can be utilized, where you can call up, maybe I have a webhook where we can actually call that endpoint and get those information and maybe somehow create that policy, right? So I see a lot of potential there with this particular capability, where we extend to external service calls, where Kyverno can actually call any service endpoint within the Kubernetes cluster, right? Again, software supply chain security, not much talked about in this particular event, but that it's a major requirement today for many organizations, especially those who are already matured, are already taking that route. And there are these compliances called SALSA compliances. Now, one of the fundamental requirements for SALSA and supply chain security is signing of images, right? And signing of images, again, there are two ways today, most popular ways through which you can do that. One is cosign, and the other is cosign sigstore, and the other one is notary. Now, we support both from a signing perspective, signing and verification perspective, where Kyverno can integrate or interwork with cosign and notary, and get it signed, get the image signed as well as verified. And verification is where Kyverno comes in, validating those signatures. But Kyverno can also do a little bit more beyond that, beyond validation of signatures, which I will talk a little bit about. I don't know how much time do I have left.
4:27.
Okay,
so you can take few points.
So yeah, in addition to that, there are a few other capabilities that we have added, like distributed tracing. Now, distributed tracing is not for external applications, it's more for Kyverno, so that you can get to see how the requests are being processed, right? And also config caching, where instead of Kyverno going all the time and looking up to config map, you can actually cache the config map information to Kyverno itself. So those are some of the performance improvement capabilities that we have brought in. And there are many more features. So the latest release 1.11 will be released during KubeCon NA. And there are some major announcements that we are going to make, including, I don't want to, maybe because it's recorded, I don't want to mention that, but there are some interesting surprises that you will get to see, because there had been a lot of requests in terms of moving out of Kubernetes, and I think I heard some questions on serverless. So there could be some interesting, announcements there as well. And I would say, if some of you are, I don't know, is there anyone going to Kubernetes KubeCon NA from here? You are, of course, going, yeah. So, or if you know any colleagues of yours, please let us know. And, obviously we are present there, and I'll give some more details there. But yeah, so this is, I think, coming to the use cases, right? Again, these are not elaborate. I said there are 92 policies today in the community, and you can go check that out. But then, some of the core policies, top use cases that we have seen enterprises using here, we are bucketing it into 3 layers, right? So SecOps, DevOps, and FinOps. These are the 3 areas where we are bucketing it. And I think some of the core use cases that comes to mind first, or we call it as the baseline policies, because many a times, enterprises or individuals would ask you, how do you get started, right? Where do I get started? And we would always say, as a baseline policy set, first of all, you should start with pod security. Now, pod security, when we say, of course, you had legacy, which is PSP, pod security policy, which is now, let's say, superseded by PSA, which is pod security admission. But then what we believe is that there are a lot of gaps within that PSA as well, and which is where we have seen, or we have kind of positioned Kyverno as an alternative to that. And there are multiple reasons why we have. So there's an elaborate blog on that as well. And if you have any clarifications required, I can explain on that or clarify on that. But what we have seen, and what we have seen enterprises also doing, is evaluating Kyverno as an alternative to move out of pod security policy, because Kyverno 1, it enforces all the policies which are mentioned in the pod security standards. Pod security standards, or PSS, is the standards recommended by the Kubernetes project. But at the same time, pod security per se is only applicable to pods, right? It's not applicable to any other resources, right? Whereas if you want to bring in policy framework, you need to have a comprehensive policy framework for your environment. And that's where Kyverno would be, going far beyond what you can get with pod security. If you only want to do pod security, obviously you can go with PSA, but then PSA also has limitations. So we have seen increasingly customers or enterprises moving out of PSP, looking at Kyverno as an alternative, and actually moving to Kyverno. And there are some very big names which are public adopters, and you will see those names in the GitHub. Image signing I just mentioned. So just to add to what I mentioned earlier, while in addition to verification of the images, so this is a second, let's say, top use case that we have seen enterprises adopting. So one is, of course, image verification, which is the signing part of it. But then there are a few other things which are required from a SALSA perspective. One is provenance, right? So provenance of data, both the source code as well as images. And there are ways in which you can create provenance. So once you create provenance, then comes the vulnerability scanning reports. So let's say you create reports using whatever tools you want. Eventually, that will be a report either in JSON or in some other format. You may also have to come up with SBOMs, which is software bill of materials. Again, there are formats for it like Cyclone DX or SPDX. And then you have so provenance is covered, SBOM is covered, and then you have this. The provenance, SBOM, and then the vulnerability part, right? So there are 3 parts to it, three what we call as the metadatas, right? And then you have the signing part. So metadata again needs to be attested, right? So you have attestations to be done. Again, there are other tools for it. So once you do all these and then you push it to Kyverno, it can do validation of the signing, and also it can go through each and every artifact or metadata which has been created, whether it's provenance, whether it's SBOM, or whether it's a vulnerability scanning report, write policies which can prevent or allow images based on that. So just to give you an example, let's say if you have a dependency in SBOM, which has a vulnerability, okay? Let's say, for example, Log4j. If you had a policy at that point in time, we have a policy for a quick fix of Log4j at that time. But let's say if there is Log4j, a particular version which had a vulnerability, and so you suddenly want to, obviously you cannot manually do anything about it, but you can write a policy which can prevent any application which has Log4j, a particular version, in that dependency using an SBOM. So Kyverno can read the SBOM artifact metadata and then look at what version it is. And if it is a particular version which should not be allowed, then it will prevent it, right? So that's one use case. The other use case is where you look at the vulnerability scanning report, and they usually give these ratings for critical, medium, and high. You can write a policy saying, if the critical is more than 0, don't allow, right? So those kind of policies can be written, which can then enforce the SALSA compliance in your pipeline. So that's again a major policy use case that we are seeing. Multi-tenancy, finally, which I was mentioning earlier. Again, this is something which is done using generate policies, where you can essentially bring in isolations using policies with Kyverno with the generate capability. So with this, I just wanted to kind of introduce you to some of the community URLs, and now of course this will be available later on as well. So I would request, if you guys are interested, or recommend that you look at our Slack channels, be part of it. It's a CNCF, by the way, it's a CNCF project. So all the governance mechanisms from a community perspective is maintained there. You can join the Slack channel or community meetings, which are monthly or weekly. We also, Nirmata has also started off something called office hours for Kyverno, where you get to meet and talk to the lead maintainers of Kyverno on specific areas. And we have a YouTube channel where a lot more use cases are mentioned there. And by the way, in India and in Bangalore, we have also started having a meetup similar to this. Essentially because personally, we have found it very difficult to explain why governance is required. Because see, the moment I or anybody goes to somebody, right? So they would say, okay, I have a scanning tool, I have a runtime security tool. Okay, why do I need your policy engine? Because I am done with scanning. I know that there are vulnerabilities which I can fix. I have at the node level, I have a runtime security tool. Nobody really talks about cluster security. That is what we have seen mostly, right? Everybody talks about all of the other peripheral things or the local things. But I think this is some area which needs a lot more awareness beyond scanning, vulnerability scanning, and kind of node-based runtime security, or even the other aspects of management of Kubernetes, like infrastructure as a code and GitOps and so on. By the way, Kyverno works seamlessly with GitOps, like Argo CD. So there are use cases where you can, because this is a YAML artifact, and again goes back to the Kubernetes native the capability here. It's just another YAML, right? So you can actually use policies to be deployed by Argo CD at scale on any of your deployments or any of your environments, and so it works seamlessly. It also works with Crossplane. So if you have used Crossplane for managing multiple clouds, there are great use cases there as well, where Kyverno works with Crossplane. In fact, we have now come up with a term called backstack. So backstack is essentially about it's a platform engineering stack. So essentially, which means that, let's say if you have IDP with Backstage, okay, deployment using Argo CD, Crossplane being the multi-cloud management layer, then Kyverno can be your governance option, right? So BACK, backstack, is something which we are seeing a lot of matured organizations adopting, because when you have Crossplane, which is again running on Kubernetes, to manage non-Kubernetes resources, again you can enforce policies there, indirectly managing your non-Kubernetes environment. So we are seeing great use cases there, and happy to see more people probably getting involved here from India as well, because I don't see too many people in the community today. I see most of them coming from US, Europe, and other areas. I've been desperately looking at Indian names there in the community and seeing if I can talk to them. So that is one meetup that we have also planned here. So it happens bi-monthly. So happy to have you guys come in. Again, certifications, I think somebody was asking about this. So Kyverno certification is free, available for free. It's kind of fundamentals of Kyverno, which you can take up to understand better on this. So in summary, essentially Kyverno works across all the way from code commit. It can be seamlessly integrated with GitHub Actions, and from the commit to runtime on the deployment layer as well. And there are multiple use cases which I mentioned, which can be considered using Kyverno. So one point which I want to mention, this is the topmost point, is that I think governance is a must-have. So you may have security at all the other layers, but if you leave the cluster security to be open, like I said earlier, it's a breach that you are allowing to happen. There's no other way you can fix a misconfiguration once it goes to the cluster, right? Especially if it is workloads which are very critical, it's not easy for you to pull it back. And that's where you should prevent it rather than detect it. And prevention requires something like an admission controller. There is no other option today in the Kubernetes architecture which can prevent misconfigurations without an admission controller, right? If because there are two entry points to the environment, right? So one is through the API server, the other is through the application, right? Essentially, these are the two entry points. Now, if you are making a mistake at the API server, that's when you allow others to exploit. If you're not making a mistake, which is very difficult to have 100% error free, that's when others try to breach in. For example, somebody can utilize a breach on the application side, get hold of your container, and if the container is running as a root, or if the container has privileges, then you can do a container breakout or escape, right? So the reason is not because he's smart enough to enter, but the reason is because you have not been able to put the right configurations there, right? If you had all the configurations there, he cannot move beyond that particular container, right? And security context is a great example. I mean, if you don't do anything else, at least you should take care of security context, because that has a lot number of configurations, like all the host PID, IPC, network, and port, and so on. All of those configurations required to be configured. It's not secure by default, and that's one message which also I want to give. None of these configurations are secure by default, except if you are going with a commercial distribution like OpenShift and Rancher. They may have some defaults, but then every application requires different configurations. At some point in time, you will change the configurations, and then it will remain as is, and that can lead to misconfigurations, right? So I just want to also announce that we are on KubeCon this time. We have 6 sessions, 1 workshop, and 2 booths, one for Nirmata, the other for Kyverno, being a CNCF project. So if any of your team members or you are going, happy to introduce you to our team in the US, and we can talk more there, right? So with this, I think I might have covered most of it. There's a lot more to actually discuss, and it's a great area of debate and discussion. So happy to take this offline after this. And now I'm reachable on LinkedIn. This is the easiest way you can reach me. If you have any new ideas to discuss, or if you have any problem statements to solve, just let me know, and we can talk more about it, right? I did not want to get into what we do from a commercial perspective, but of course we work on top of this. We build on top of this and come up with an enterprise grade solution. So I think I might have covered most of it. I know 30 minutes is little short for me to kind of explain everything. But if you have any questions here, please let me know. I can answer some of them now, and maybe I can take it offline after this. Yeah.
Okay, you mentioned regarding the 4 categories, like 4 C's.
Correct.
My question is 2 parts. Let's say globally, what are security issues and which C? Okay, which is the highest and which is the lowest, you can say.
Okay.
Second part is which is the most challenging for you in your experiences, which out of these 4, most challenging?
See, like we said earlier, right? So in security, there is no rating. You cannot say what is most important. So you cannot go by that.
No. What you might have faced it. That's my
I think, see, all the layers are important. So I'm saying all the layers are important, and there are different owners for it. For example, when we talk about cloud, there's a shared responsibility, right? So shared responsibility, depending on where it is hosted, if it's on-prem or on the cloud, there'll be different owners for it. But of course, cloud also has multiple components to secure. Again, when you look at cloud, the traditional levels of security like perimeter security, DDoS and firewalls and so on. I would say personally that if you look at Kubernetes, not because I am working in Kubernetes today, the nuances are much more fine-grained compared to some of the other components that we are talking about. For example, AppSec. When we say AppSec, I think much of the principles today, except zero trust, which is now kind of there everywhere. I think it's kind of traditional. I would say traditional in the sense that a lot of things have been done, a lot of experiments have been done. So I think it's kind of a saturated, matured environment for AppSec. SAST, dynamic analysis and so on, which has been done. On the cloud layer also, the level of number of components that we see, I think, are limited compared to what you see in a Kubernetes environment, because there are so many components which together constitute the Kubernetes ecosystem. And it's very difficult for you to actually maneuver or navigate through that. So I would say the complexities are pretty high here on the container and the cluster side, is what I would say. But there's no prejudice here, right? So I'm saying even if you have done everything here, if you have not done anything here, then you're done, right? So I would say everything is important.
Okay, the one is important, that's fine.
Yeah.
But what about challenges? Which layer more challenges you find it?
No, I would say, I personally
Container.
would say cluster and containers, yes.
Okay, okay, thank you.
It's all subjective, right? I don't want to
Yeah.
really put that as a.
Yeah, it gets
Yeah.
right.
On the infrastructure side, I would say Kubernetes is a challenging task. Yeah.
Uh-huh.
Yeah.
Okay, thank you.
Right. Any further questions? All right. Seems like everyone's tired already.
Yeah. I think I can see some sleepy faces. So
Right. Right. Being respectful of everyone's time,
Yeah.
we have two more speakers, Vivek from Amdas and Avinash from Platformatory.